Hello, beautiful people. I'd like you to do two things. Number one, go ahead and check your answers on the review warm-up from the pictures that I posted. And then number two, if you got anything wrong or if there's anything you're not sure about, go ahead and check that part out on this video. For these problems, I only want you to do numbers 1 and 2, just for numbers 1 and 2. We will go over 3, 4, and 5 at another time, but not today. I just want to go over what you might need in order to do today's lesson. So number one asks you to find the slope of the line that passes through the given points. First thing I like to do is label x, y, x, y. The first pair gets the 1s and the second pair gets the 2s. And then as a reminder, my formula for slope is m equals y2 minus y1 over x2 minus x1. So for me, my slope is going to equal, plugging in y2 is negative 4, minus y1, which is negative 4, what a coincidence, over x2, which is 4, there's a lot of 4s in this problem, minus x1, which is 6. Now, as you know, if you know me at all, you know that I like to add the opposite when I'm subtracting. So up top, I'm going to have negative 4 plus a positive 4, that's 0, over, adding the opposite here, 4 plus negative 6 gives me negative 2. Whenever I have 0 in the numerator, that means that my slope is going to be 0. So if this was a line, it would look like that. It'd be a nice horizontal line for you. 0 slope for that one. This is 0 fun, if you remember slope, dude. Okay, number 2. Now this is the stuff that you most recently learned. Rewrite the equation in slope-intercept form. Slope-intercept form, as a reminder, is y equals mx plus b. Notice as I read, I kind of like to decode a little bit. And then it says identify the slope, which we're using as m, and the y-intercept, which is b, and then graph, which is why they gave us this lovely graph here. So in order for me to do that, the first thing I'm going to do here is to get the y by itself. So I'm going to subtract 5x and subtract 5x. Remember that we always get rid of addition and subtraction before multiplication and division. So I have 2y is equal to negative 5x plus 10. Then what? Then I'm going to divide by 2, divide by 2, and divide by 2. What do we have left? Well, these y's cancel out. This is a fraction. I'm good with it. I do not want a decimal because that makes it difficult for me to graph. So I'm just going to write it as a fraction, negative 5 over 2x plus 10 divided by 2. 2 goes in that evenly, so I'm going to put 5. So they asked me what my equation is. My equation is y equals negative 5 over 2x plus 5. My slope, remember if I line this up to y equals mx plus b, well, what's in the m spot? That negative 5 over 2. What's my y-intercept? If you said 5, I would take off a point because I like to write it as a coordinate, so 0, 5. Perfect. So the y-intercept, we know it as b. And b is where I will always begin. So 1, 2, 3, 4, 5. And then my slope tells me where to go. So if my slope was negative 5 over 2, then this, here's a reminder, rise over run. This is a negative 5, so that's telling me to go down 5. And this is a positive 2, so that means I'm going to go right 2. So down, 1, 2, 3, 4, 5, and right, 1, 2. Do it again. Down, 1, 2, 3, 4, 5, right, 2. Perfecto. Then I will connect my dots. Ladao. One more thing for me to do. Label y equals negative 5 over 2x plus 5. Now, it's a little crammed up, and you can kind of barely read what it exactly says, but I know that it's there, and I know that it's labeled, and that makes me happy. Okay, let's talk about direct variation, number 3, next time, and number 4, also direct variation next time as well. Kind of. It might actually help you today, so I'm going to remix my plan. Let's do 3, 4, 5 real quick. Direct variation, y equals kx, where k is my constant of variation. And the thing I want you to know about that, it's not that different from what we just did with slope-intercept form. The only difference is that the b is 0. One more time. The b is 0. That means it's always going to go through the vertex. I'm sorry, not the vertex. Just kidding. The origin 0, 0. So the same thing I just did, just to get a little bit more practice, I'm going to get the y by itself by subtracting 2x. And I have y is equal to negative 2x plus 3. That's a problem. For direct variation, it can't be plus anything or minus anything. So I'm going to say, nope. This is not direct variation. Now, number 4 is different. This says, given y varies directly with x. This is the interpretation of that. Y varies directly with x. Use the specified values to write the direct variation equation. So that's the first thing I want to do. Actually, that's the only thing I want to do. So I want to find the k in order to do that, though. So I'm going to plug in the y, which is 7, equals k times x, which is 14. I want to find out what the k is. What is the constant of variation? So I'm going to divide by 14. This is not 2, it's 1/2 is equal to k, because I can reduce that by dividing by 7 and dividing by 7. So my equation is going to be y equals 1/2 x. Gorgeous. Okay, lastly. Oh, so that's all I want when I do that. I just want the equation. So for that one, I just want the constant, and then I could write that. Write the equation of the line that passes through. Oh, that passes. That's a typo. That has a slope of negative 1/2 and a y-intercept of 7. Let's label my parts. Slope m, negative 1/2. Y-intercept b, 7. Beautiful. And we know that y equals mx plus b. So y equals negative 1/2 x plus 7. And that is my equation of the line in slope-intercept form. Now, if I were to get stuck on my classwork, I could always ask someone for help. And I can also, because my directions are the same in your notes as they are on here, I can also just go ahead and just fast forward to the problems that I'm having a problem with. All right, that's it for me. Have a delightful day, and let's get to that classwork. Thank you.